When astronomers first detected Proxima b, a planet orbiting the faint red dwarf Proxima Centauri only 4.2 light-years away, it instantly captured the world's attention. Its closeness to Earth and its location within the star's habitable zone made it one of the most intriguing places to search for life outside our solar system. Proxima b receives almost the same amount of stellar energy as Earth does from the Sun, hinting that, under the right circumstances, liquid water could exist on its surface, a key ingredient for life. But living next to a red dwarf star is far from peaceful. A hostile neighborhood, Proxima Centauri is a restless star that often erupts with violent flares and radiation bursts. Such storms could strip away a planet's atmosphere unless it has a strong magnetic field for protection, something scientists haven't yet confirmed for Proxima b. Without that shield, water would quickly evaporate, and life would struggle to survive. However, some planetary models suggest a fascinating alternative. If Proxima b is tidally locked, meaning one side always faces its star while the other remains in darkness, there could be a temperate ring between the two extremes, known as the terminator zone. The twilight band of life. In this narrow twilight region, the blazing heat of the day side and the deep freeze of the night side could balance out. If an atmosphere is present, it might spread warmth around the planet, creating an environment mild enough for liquid water, and perhaps even microbial life. Imagine rocky plains bathed in perpetual dusk, where moisture gathers from thin air and strange organisms adapt to the dim red glow of their star. It's a haunting but hopeful vision, one that continues to inspire scientists and dreamers alike. The role of the James Webb Space Telescope to test these possibilities. Astronomers have turned to the James Webb Space Telescope, JWST. From its position beyond Earth's atmosphere, JWST can study the faint starlight that interacts with a planet's air, revealing chemical fingerprints of gases such as oxygen, methane, and carbon dioxide, potential signs of life. But studying Proxima b is particularly challenging. The planet doesn't transit its star from our viewpoint, meaning JWST cannot easily observe light passing through its atmosphere. Scientists must rely on indirect techniques, analyzing reflected light or the subtle wobble in the star's motion caused by the planet's gravity. Upcoming instruments like the Extremely Large Telescope, ELT, in Chile will provide sharper data, possibly uncovering details about Proxima b's surface composition, temperature variations, or even cloud patterns. Listening for other civilizations beyond chemistry, researchers are also listening. Projects such as Breakthrough Listen have pointed powerful radio telescopes toward the Proxima Centauri system, searching for structured or repeating signals, hints of technological life. Nothing conclusive has appeared yet, but Proxima b's nearness makes it an ideal target for continued monitoring. What could alien life be like there? If life exists on Proxima b, it would likely be very different from Earth's. Under a red sun, photosynthetic life might use infrared light instead of visible light. Some organisms could live underground or beneath ocean layers, protected from the star's harsh radiation. Here on Earth, extremophiles, microbes that thrive in boiling acid, deep sea vents, and radioactive zones, prove that life can adapt to almost anything. If Proxima b has underground water or geothermal activity, such organisms could survive there as well. A target for future exploration. Because it's our closest known potentially habitable planet, Proxima b has reignited serious discussion about interstellar travel. Concepts like Breakthrough Starshot propose sending miniature, laser-propelled probes that could reach the Proxima system in a few decades and send back images and data. Our first glimpse of an alien world up close. Caution and wonder. Despite all the excitement, scientists remain cautious. Proxima b's closeness to its volatile star could have exposed it to billions of years of harsh radiation, possibly eroding its atmosphere. Yet its estimated mass, about 1.3 times that of Earth, suggests it could be rocky with a metallic core capable of generating a protective magnetic field. And Proxima b may not be alone. Within the Alpha Centauri system, our closest stellar neighborhood, astronomers have detected hints of other worlds, some orbiting within what could be their own habitable zones. Alpha Centauri A and B, both Sun-like stars, may host planets where temperatures allow water to remain liquid. If confirmed, this would mean that just a few light-years from Earth lies not one, but several potentially habitable worlds. A cluster of opportunity at the edge of our cosmic doorstep. Such discoveries transform how we see the night sky. Those faint points of light are no longer distant, lifeless fires. They are gateways, each possibly surrounded by entire systems of planets. And among them, Proxima b stands out as a symbol of possibility, a reminder that we might not be as isolated as once believed. The broader vision whether or not life exists on Proxima b, the planet has already achieved something extraordinary. It has reignited humanity's imagination. It has made us look outward again, beyond the boundaries of our own world, and wonder what lies in the darkness between the stars. Every new discovery brings us closer to understanding our place in the cosmos. Proxima b reminds us that the universe isn't a silent, empty void. It's a dynamic, evolving landscape filled with potential. Each exoplanet we find adds another piece to the cosmic puzzle, shaping a clearer picture of how common, or rare, life might be. The search for life is not just a scientific mission, it's a reflection of who we are. Our curiosity drives us to explore, to ask questions that reach beyond survival, questions about meaning, existence, and connection. The challenge of distance. Yet even though Proxima b is our nearest neighbor, it remains unimaginably far away by human standards. Traveling at the speed of our fastest spacecraft, a journey there would take tens of thousands of years. That vast distance is both humbling and inspiring. It forces us to confront the scale of the universe, and the limitations of our technology. But it also sparks innovation. Projects like Breakthrough Starshot are daring to imagine a future where light-powered probes could reach Proxima Centauri within a single human lifetime. If such missions succeed, they would send back our first close-up images of another Earth-like world, the first real glimpse of alien skies, foreign landscapes, and perhaps even the chemical fingerprints of life. The day that data arrives, humanity's understanding of itself will change forever. The deeper meaning but Proxima b's importance goes beyond science and engineering. It speaks to something deeply emotional, our longing to connect. Throughout history, humans have looked up at the stars seeking stories, gods, or guidance. Now, for the first time, we are close to finding truth instead of myth. If life exists there, even microbial, it would prove that biology is not unique to Earth, that life is a natural outcome of the universe itself. That realization would reshape biology, philosophy, and religion alike. It would mean that wherever conditions allow, life finds a way. And if Proxima b turns out to be barren, lifeless, or scarred by radiation, even that would teach us something profound. It would show how fragile habitability can be, how precious Earth truly is, and how carefully we must protect it. Echoes of home. There's a strange beauty in the idea that our nearest star system might mirror our own in miniature. A small, rocky planet orbiting a faint sun, waiting to be understood. In that reflection lies a question older than civilization itself. Are we alone? It is a question that echoes through every generation, in every language. It has driven poets, philosophers, and explorers for centuries. And now, armed with telescopes that can see to the edge of time, we are finally in a position to begin answering it. Each signal we listen for, each spectrum we analyze, each planet we discover, it all adds to the growing realization that we live in a universe of endless possibilities. The search for life, in truth, is also a search for understanding ourselves. The endless frontier. Our exploration of Proxima b is not just about finding alien organisms. It's about the future of humanity itself, about the kind of species we choose to become. Do we remain bound to one world, vulnerable to chance and change, or do we reach outward and embrace our role as explorers of the cosmos? The quest doesn't end with one planet or one telescope. Future missions, from next-generation observatories to interstellar probes, will continue this journey, extending our senses farther than ever before. And someday, whether through data, signal, or voyage, we may finally know for sure what lies around that small red star. The beginning, not the end. So as we gaze toward Proxima Centauri, the faint red glow in the southern sky, we are not just looking at another star. We are looking at a reflection of our hopes, our questions, and our determination to know. Proxima b is not just a planet. It is a message, a reminder that the universe still holds secrets worth chasing. The search for life beyond Earth is far from over. In fact, it may have only just begun. Because every discovery, no matter how small, brings us closer to the moment humanity has dreamed of for millennia. The moment when, somewhere in the cosmic dark, we finally hear a whisper that says, "You are not alone."